Today we worked with problems involving triangle similarity. So let's work with this. Let's look at this problem here. The problem says, if EB is parallel to DC, find the value of X. Okay, so parallel is a juicy word, right? It tells us that these two lines are parallel, and therefore AEB is going to be similar to ADC. Now, if we ever see two triangles like this where one is inside the other, we split them up and we make two. Here, let me put this so they're all on the white background together. And we split them up into two triangles, right? So this is going to be the small one on top, and then this one is going to be the big one on the bottom, okay? And the vertices of the small one are A, E, B, and the vertices of the big one are D, A, C. Okay? So I know that the dimensions of the small triangle, side AE, well, if the whole side AD is 10 and this piece here is 4, I know that this piece up here must be 6. So AE is 6. The other side of AE, the other side of the triangle AB is going to be X minus 2. For the big triangle now, side AD is 10, as the figure tells me. And side AC is X minus 2 plus 5, because it's going to be this whole piece right here. I simplify this, I combine like terms, and I get X plus 3. So now I have two sets of corresponding sides, and I know that they're proportional because the two triangles are similar, so I'm going to set up my ratio. 6 goes to 10, and I started with the small triangle, so I have to start with the small triangle down here, as X minus 2 is to X plus 3. So now I'm going to cross multiply, and I get 10 times X minus 2 equals 6 times X plus 3. I distribute the 10 to each thing in the parentheses, right? I distribute the 6 to each thing in the parentheses, and I get 10x minus 20 equals 6x plus 18. I simplify and I get 10x equals 6x plus 38, because I plus 20 on both sides. I minus 6x minus 6x, I get 4x equals 38. X equals 9.5. So the value of X is 9.5. Next problem. This one we're going to have to construct two similar triangles, right? So the problem says Alex is standing next to the Palmetto building in Columbia, South Carolina. He, meaning Alex, is 6 feet tall, and the length of his shadow is 9 feet. If the length of the shadow of the tower, is 322.5 feet, how tall is the tower? Okay, so we have Alex, right? And he's standing next to a building. Okay. Beautiful building, I know. Now, Alex is 6 feet tall, okay? And the length of his shadow right here, is 9 feet. The length of the shadow of the tower is 322.5 feet. So I have created two similar triangles here, right? Now I just need to find how tall the building is, or the tower rather. So now I can set up my ratio, right? X from the big triangle is to 6 from the little triangle, as 322.5 in the big triangle is to 9 in the small triangle. I cross multiply and I get 1935 equals 9x. Divide both sides by 9. X equals 215 feet. Therefore, the height of the tower is 215 feet. Okay, so these questions are always going to ask you to kind of create an original, a big one, and then compare it to a small one. So create the parent and compare it to the kid. Let's look at this one now. Gavin and Brianna want to know how far a mountain peak is from their house. So we want to know how far the peak is from their house. Okay? Their house is, sorry. They measure the angles between the line of sight to the peak and to each other's houses and carefully make the drawing shown. Okay, so the line of sight is always going to be this one up here. It's the straight line with which they look at the peak. And then the distance from their houses to the peak, the distance from the houses to their peak is going to be this one right here. Okay, now in this figure down here, it says the actual distance between Gavin and Brianna's house is 1.5 miles. So this is the angle of Brianna's house to the peak, and then this is the angle of the line of sight up here. Okay? So this is the model because it's in inches. It's much smaller. It's a model. Okay? And now this is going to be the actual over here because they give us the actual distance, which is 1.5 miles. So 1.5 miles is going to be the distance between the two houses from the house here to the house here, right? And we want to find out what is the actual distance, so we're going to be in the actual figure, this figure here, of the mountain peak, remember? Ooh, I hate when it does that. Okay. Remember, the mountain peak is over here. This is the peak. From the mountain peak to, from Gavin's house to the mountain peak. Okay, so this is Gavin's house up here. I'm sorry, this thing keeps moving around. Okay. All right, so Gavin's house is the one on top, and it's the distance from Gavin's house to the mountain peak, okay? So if we look at the triangles up here, our corresponding sides are going to be the distance between the two houses, so that's 0.246 inches is to 1.5 miles. Now we're looking for the distance on the top, right? From Gavin's house to the mountain peak in the model is 2 inches. And then in actual life, it's X. We don't know what it is. Okay? So our units line up, so we know that we've set up the proportion correctly. Now let's cross multiply. What do we get? So I cross multiply. Now I have to get X by itself, so I divide both sides by 0.246. And I get X equals 12.195122. Okay, now look at the question, right? It says round your answer to the nearest tenth of a mile. Remember what the tenths place is? Let's say we have a number 365.4. The tenths place is the first place after the decimal point, okay? So if this is the answer that we got, we need to round it to this point right here, and we'll get 12.2. And that's our answer for the first one. So the second part, it says, what is the actual distance? Wait, let's put that in the figure, right? 12.2. Okay. What is the actual distance? So we're working in this figure here, the actual figure, right? What is the actual distance of the mountain peak from Brianna's house? Remember, Brianna's house is the one down here. So we're looking for this distance now. Let's call it Y. Okay? Round your answer to the nearest tenth of a mile. So we're going to round our answer just like we did last time. Okay? So let's set up our ratio, right? We have the distance between Gavin and Brianna's house in the model is 0.246 inches. Don't forget your units. And that corresponds to 1.5 miles in the actual figure. And the distance between Brianna's house and the peak in the model is 2.015 inches. And in real life, we don't know what it is, it's y. So let's cross multiply, and we get 0.246y equals. And we get 0.246y equals 3.0225. I divide both sides by 0.246 to get y by itself. I get y equals 12.2865. Now remember, the question told me to round my answer to the nearest tenth of a mile. So I'm going to have to round to this digit right here. The number before it is 8, so I'm going to round up to 3, and I get 12.3. Okay. Next problem. So this is the MCAS problem that we went over on the board today. Let's read the problem. It says, triangle RST is an isosceles triangle. Remember isosceles. Very important word. It tells us that we have two congruent sides and two congruent angles. Isosceles triangle with congruent sides RS, okay, and ST. Got it. Point M lies on RS, and point N lies on ST. Okay, here they are. Point M, point N. MN is parallel to RT. Remember, every time they tell us that two lines are parallel, we put the little arrows, and we know that we're going to have to use the angles from a transversal, right? Last, it says the length of SN is 23 feet, and the length of NT is 10 feet. All right. The first part, A, asks us, what is the length of RS? RS is this right here. What is the length of that? Well, on this side over here, on the side ST, we have 23 feet plus 10 feet gives me side ST, right? And I know because triangle RST is isosceles, that side ST is congruent to side RS, therefore RS equals 33 feet. You need to write out all this stuff because you can't just write 33 feet. The MCAS wants to know why you got 33 feet and if your reasoning is correct. So you have to write all these steps out. Okay, B. What is the measure of angle T? Show or explain how you got your answer. Okay, so angle T is the one right here in the corner. Angle T, okay? Now look, we made a marking on this figure that says angle T is congruent to angle R, right? If the problem tells us that 50 degrees is angle S up here, and that R and T are congruent, we can call these both X and set up an equation, right? So we'll get 2x plus 50 equals 180 degrees. Solve for x, I get 2x equals 130, divided by 2, x equals 65 degrees. As soon as I get my information, I put it in the figure, right? So I'm going to put that into the figure, 65 degrees, right here. Okay. Part C says, what is the measure of angle MNS? Show or explain how you got your answer. Okay, let's find MNS in the triangle. Angle MNS. Remember, the vertex is in the middle. The vertex is the middle letter. So we're talking about this angle right here. You need to know how to read angles, right? If I had this angle written over here, right? Angle M. Hold on, it would be facing the other way. It would be facing this way, right? We would have M, N, S. N is always going to be the vertex, okay? So we have angle MNS. We are trying to find the measure of angle MNS. So remember before when the problem told us that these two lines are parallel? Well, think about a transversal, right? If we have two lines that are parallel right here, and this side, ST, is cutting through the transversal, we have angle T right here, which is this one, and then we have angle N right here, which is this one. So as soon as the two angles are on the same side, they are together, so it's either going to be corresponding or consecutive. Now we know, because they're on the same side of the transversal, one is in, one is out, these are corresponding angles. So the measure of angle MNS is going to be congruent to the measure of angle T because they are corresponding angles. Angle T is 65 degrees, therefore angle MNS is 65 degrees as well. And you need to write all that stuff out, otherwise you're not going to get full credit, okay? So D, explain why triangle MNS is similar to triangle RTS. Okay, so triangle MNS is this top one right here. As soon as we start comparing the two triangles to each other, we got to split them. Then we know exactly what we're talking about, what parts we're talking about, okay? So this is triangle RST, and that's the big triangle. And then the small one is going to be MSN. And we know the triangle N and the angle N is congruent to angle T because they're corresponding angles. And we know the same is true on the other side as well. Angle R is congruent to angle M because they are corresponding angles. And we know that S is congruent to angle S because they are a common angle. They're both 50 degrees. So the question is asking us, explain why triangle MNS is similar to RTS. Now we have three congruent angles, but remember, all we need to prove that two triangles are similar, MNS is similar to RTS, is two angles. So we're going to use the angle similarity postulate. And the two angles that we found to be congruent were angle M is congruent to angle R because they are corresponding, and angle T is congruent to angle N because they are corresponding. So we know that those two triangles are definitely similar. Last, we have part E. It says, what is the length of MN? MN is this line right here, MN. Okay? What is the length of that? Let's look at our split up figures, right? Let's start labeling these with some sides now, okay? So we know that side ST is 33 feet. We found that earlier in part A. And we know that triangle RST is isosceles, so the other side is going to have to be 33 feet as well. The figure tells us right here that the bottom is 28 feet. And now we look at the figure again, and it tells us that side SN is 23 feet, and we know that this is an isosceles triangle as well, so side MS is going to have to be 23 as well. We're looking for the length of MN, so MN is what we're going to call X. Let's set up the ratios that we know that we're masters at by this point, okay? So side SN, look at our similarity statement. Side SN corresponds to side TS, okay? So SN is 23, and that's going to correspond to 33. And then MN, which is X, corresponds to RT. X corresponds to 28. We cross multiply, and we get 33x equals 644. Divide both sides by 33. X is equal to 19.5, and we're done. So look how I labeled everything. I showed where all my answers go with each thing. That's how we want you to set up your work, okay? If you don't show us where the answer to part A is, we're going to assume that you did not answer the question. If you don't show us where the answer to part B is, so on and so forth, okay? And then last, I just wanted to show you this because a few students asked me about it earlier, and I think it's worth going over, right? So So remember on the first day of similarity when we discussed that corresponding sides of similar figures are proportional? And then we set up this ratio where we showed what we meant by that, right? We said we mean that side AB is proportional to side FE, side BC is proportional to side FG, side CD is proportional to GH, and side AD is proportional to side HE, okay? And we showed that if all of these are similar, their ratios will be the same, right? And this ratio was equal to the ratio of the perimeter of the first figure to the perimeter of the second figure. Then we showed the same ratio, except this time, if we squared the length of each side, we would get the ratio of the two areas. Do you remember this now? We would get area over area. Okay? So we're not going to be working with the perimeter one today, but I just wanted to show you so it would jog your memory. But we will be working with this area proportion down here today. Okay? So in this figure, it tells us, it just gives us the area of the first figure and the area of the second figure, and then it just gives us one side. Okay? The question says, find the missing side if the figures are similar. So if we know the figures are similar, we know that their sides are proportional, and therefore if we square each side, the areas will be proportional. Okay? So if we set up a ratio of A side AB is proportional to side FE, and we square both of those sides, we should get the ratio of the area over area, right? Because the proportions are equal. So if the given area of the first figure is 5, and the given area of the second figure is 20, we can substitute our known value for AB into the equation. Oh, sorry, that's a 5, not a 3. Oops. 5, okay. And we don't know what FE is, what side FE is, okay? So we're going to get 9 equals 5 over 20, and let's just call side FE x for now, okay? I cross multiply, I get 5x squared equals 180, divided by 5, divided by 5, x squared equals 36, x equals 6. So the side here, x is 6. And the reason why is because the ratio of the two sides squared is equal to the ratio of the area in proportional similar figures.